1.6 is graphical transformations.
We're doing these again.
These again because this is review a lot from
This is like third year
Algebra 2. Okay.
Say, we use these in, do we use these in Geo?
You might see them in Algebra 1
Algebra
some.
1, I think that's what I'm thinking.
But yeah, so this is review. I will say I feel like every time you see these, you get them at a little bit higher level, if that makes sense. And so, you know, a little bit higher level than what you see in Algebra 2, but a lot of the same stuff. So we're just going to kind of run through all of it, go through some examples. And as I said, the ideas themselves will be familiar. So you have this chart here. Horizontal translations. Hopefully you remember from last year. When a value is being added or subtracted in parentheses, or to the x, in parentheses, an absolute value, inside a square root sign. But in with the x, that's going to be your horizontal translation. And remember, I always say you go left or right, opposite the sign. Yes, you've heard me say that for a full year, so it's burned in your brains. So a minus c takes you right, a plus c takes you left. And we have vertical translations. If your number is add or subtracted on at the end, so it's not in with the x, you're going up or down. That is the direction of the sign. Okay. Reflections. The first two are the same as last year. I don't know that we did a whole lot. We did some with reflections. We'll do a little bit more this year. But if there's a negative out front, so negative out front of the whole equation, it's going to be reflection across the x-axis. Okay. So I think of negative on the whole equation, it's like making a negative y value. It's going to reflect across the x. If the negative is specifically on the x, so it's in the equation on the x, then it's going to reflect across the y. So in my brain, it's an opposite relationship there. A negative x reflects across the y. Negative equation, which is kind of like a negative y, reflects across the x. Through the origin. Okay, we've talked about through the origin when we were talking about odd functions, right? Odd functions are something that are symmetric through the origin. And notice it's both negative signs. So it's the x-axis and the y-axis reflection. So through the origin there. Okay, so that's a new one. Reflections. And then stretches and shrinks or compressions. Algebra 2 book uses the word compressions, right? I want to say this pre-calc book maybe uses the word shrinks. I don't remember exactly, but just realize a shrink versus a compression, same thing. Both cases we're talking stretches. Now, the one you're familiar with is the vertical one down here. Okay, so this one where it's c f of x, I think on our paper last year it was a times f of x. But if it's a number multiplying out front, it's a vertical stretch. If that number is bigger than 1, it's a stretch. If the number multiplying out front is a number between 0 and 1, it's a shrink or a compression. That's the part we did last year. New part, this was on the forms last year, but we didn't do a whole lot with it. Okay, we didn't really talk about the horizontal aspect. This year we actually talk about the horizontal aspect. So this is if x is divided by a number. Okay, so if the number is in with x, and it has to be in a division setup, if the number is x divided by that, it's a horizontal stretch. If that number in the denominator is bigger than 1, it's a horizontal shrink if the number is between 0 and 1. Okay, this is your chart. Note the comment here. Transformations can be performed in succession, one after another. If the transformation involves stretches, shrinks, or reflections, the order in which the transformations are performed may make a difference. In those cases, pay close attention to the order. Whether you go left or right or up or down first doesn't matter. But when it comes to stretches, shrinks, and reflections, you have to watch at how the equation is set up. And we'll talk about that somewhere it comes up. Okay? Did I cover what you're going to say?
Yeah, so you just go left to right.
Not so much left to right.
In order.
Well, it's not so much left to right as you work in what's like most, what's the word I want to say here? Like what's done on the x and then work your way out, if that makes sense.
Cool.
So it's not necessarily a left to right thing.
Understand that, P?
Okay? hold the thought till we get to an example that matters, okay? Okay, so example 1 here. Describe how the graph y equals the absolute value of x, so that's your parent function, can be transformed to the graph of the given equation. So A, y equals absolute value of x minus 4.
It's gonna be going down 4.
Agree?
It's going down.
The minus 4 is outside the absolute value, so it's up or down direction of the sign down. He says it's going to be going down 4. I'm going to use the word translated down 4
You
units.
remember that argument we had earlier, like a couple weeks ago? That wasn't really an argument. I believe the word translated was in there.
Okay, B. Y equals the absolute value of x plus 2.
I have it going left 2.
Agree?
Translated.
Translating.
Translated.
Thank you.
Translated, not translating. You're not
The plus 2
translating.
is in the absolute value, gentlemen. So if it's in the absolute value, left to right, opposite the sign. So we are going to translate left 2 units. Okay. I tend to go with translate. I tend to go with translate as my verb. Shift is another good one to use too. Okay.
That's what I said last time.
Nope,
And you
it's
guys translated.
translating.
The official one is translate. And here's the deal. I'll take shift. What I hate is when people just say down 4, left 2. Like,
That's what you said.
give me something.
You said.
Okay.
Left 2.
Continuing on.
You said shift.
Okay, example 2. Write the equation for each of the following translations. So this time we're using, in part A, we're using x cubed. So we want to write the equation that shifts the graph of y equals x cubed down 3 units.
Well, you're going to put x cubed in parentheses, and then we're going to go down 3 units, then you're going to subtract 3.
And is this subtract 3 in the parentheses or not in the parentheses?
Outside. On the end.
That's why I said the X.
So are you saying, I'm trying to figure out exactly how you're saying this.
Yep.
Like that?
Yep, and then now minus 3. Yeah. That's what I'm saying.
Okay. Now,
Or the cube could be outside the parentheses.
Or, yeah, it's the
It
same
doesn't really
difference.
matter. It's all the same.
so now you're saying or. Is that what you're saying?
Yeah,
Yeah.
but I like the first version because it keeps it all together.
I like
I disagree. I'm kidding.
this version right here. You
Oh,
don't need
since-
parentheses
since
in this
it's not in
scenario.
parentheses.
Okay, but
Okay.
you gotta
Now.
do it how you're gonna have to do it when there's other numbers. So you just keep it all the same. You don't change it.
Okay. Now, listen up. All 3 of these would be considered correct. Okay. They all show equivalence in this situation. So it's the idea of the minus 3. It's not in the parentheses with the x. In this situation, because there is no left to right movement, I would say you don't even need parentheses. And that's what you would typically see. So the x cubed minus 3. Now, if you're going with, I'm trying to prepare for when I do have to go left and right, then the 3 outside would be you prepping for that. Okay, because when we start going left or right, we'll talk about that. Okay, so again, all 3 equivalent. I would definitely prefer this one I have circled. Okay.
Fair enough.
B, shift the graph of y equals x cubed left 2 units.
All right. Well, then we're just gonna go y equals parenthesis x cubed, and then we're gonna go plus 2 in parentheses.
Again, you can do it.
Wait. Hold on.
Can I just write it?
Say it again.
X cubed. Right, are we doing cube still? Left 2 units. Yeah.
So
then we're gonna go plus 2.
So like this.
Yes. And then end it. What?
Vetoed.
Oh, throw the cube outside. go X.
You're doing it to the
Yeah. And then I'll go parentheses. Yep, yep.
Okay,
Yep.
what am I doing?
X plus 2, close parenthesis, to cubed it.
Is there a difference here?
Yes.
You'll survive. Okay. Okay. Now, that one I had to veto.
Wait.
Okay. And
Do we have 2/3? Can we 2/3 this veto?
Just, you know.
Can we overturn it?
listen,
Me too.
I need us to focus, please. Y equals x cubed plus 2. Right here in this first scenario, and this is, I put it up here, I wrote it out because I want you guys to see, this is a common mistake. If we say x cubed plus 2 and you put the parentheses outside, this right here is going up 2. And that's not what we were asked to do. Okay? When it's left or right 2, your parentheses, in the parentheses is just the x plus or minus the number. The power, the square root, the absolute value, whatever it is outside of that. Okay? So, this is the one I'm looking at. I really don't have a good alternative answer that would be correct. This would be the preference.
See, I knew that. I was giving you an example for the whole class.
Okay. C. Shift the graph of y equals x minus 1 cubed, right 3 units. Logan with his hand up.
Hear me out. Y equals parenthesis x minus 4 parenthesis cubed.
Okay. Girls, are you with us?
I agree. I second this motion.
He says y equals x minus 4 cubed.
All in favor say aye.
Aye. All opposed,
Okay.
same sign? That's what I thought.
Okay. And I agree with it. Are we all clear with where the 4 came from?
Yeah.
Okay, that was, if I'm starting this, and I'm not saying you'd have to write what I'm getting ready to write at all, but the idea of it's right 3 means it's x going right 3, so minus 3, but there's also already a minus 1 there, isn't there? So it's already being moved right 1. When you go 3 farther, that puts it at a total of 4 right. Okay, so what I wrote here first, that would be okay, but it's not a good final answer. Final answer just shows that overall you're moving right 4. Okay, questions there? Okay, so a little bit of just practice with the translations, being able to take the graph. Remember where to put the powers. That's the stickiest part there. Okay. Example 3. We get to practice with reflections. Okay. And specifically, it's reflections on a fraction, which makes it a little trickier. And it just says find an equation for the reflection of f of x, and it gives us an equation. We're going to do this 3 different times. We have 3 different reflections, so we're going to practice each of the reflections. We're going to start by reflecting this across the x-axis. Okay? The first one we're going to do is x-axis.
Oh, those. Okay.
This guy.
Okay.
Well, we had to tell me we're
Now.
at the top here.
Okay. So we're going to reflect across the x-axis. In order to reflect across the x-axis, what does it say to do up above?
For an x-axis across the x, you're gonna do a horizontal. Wait, are you asking for like
Negative f.
What do we do?
x.
Negative f of x.
Negative x.
Okay, now, with that, negative f of x means you're going to take a negative, and usually how I show it the first step is I'm going to put negative out front, and then the whole equation in parentheses. In this case, that equation is a fraction. So, when it's negative f of x, that means you take the negative, and you're distributing it into the whole equation. Now, with it being a fraction, how do we multiply a fraction by a negative?
You can just make the
Just
whole
the
fraction
numerator?
negative.
Well, you're picking
You have to choose
the numerator
or the
or the denominator, or just have a negative sign out in front of the fraction bar, but I feel like that gets real tricky because you
stuff.
push it up or down a little bit, it's a question of where it is. Traditionally, we go for in the numerator, but it could technically be either or. It just cannot be both. So if we take this and distribute it to the numerator, this now becomes negative 5x plus 9, but then still over x squared plus 3.
I agree.
Okay? That is your reflection across the x-axis. Okay? Okay, now let's look at reflection across the
Y-axis.
y-axis.
For reflection across the axis of the y, you're going to do f of negative x.
That means you make all the x negative, correct?
Okay, so up above, reflection across the y-axis, it says f of negative x.
Are we making?
So that means in your equation, every place you see an x, it becomes negative x. So I'm going to write it out as 5 times negative x minus 9 and negative x raised to the second plus 3. Now this is just kind of my work step. And again, it's just to make sure everyone's on the same page. I'm not saying you have to show this work step necessarily, but I want everyone to see where we're going with this. Now, I do ask that you clean this up and not just leave it like this, because this isn't good form. Okay? 5 times negative x is going to make it negative 5x, still with minus 9 on top. What does negative x quantity squared become?
X.
Okay, so positive x squared plus 3.
Yeah, attaboy for money. Boom. Get in that little.
Okay? So that's your reflection across the y-axis. Now, those are the old news. New news is we also have something where it's a reflection through
Origin.
the origin.
Goodness me.
Now, when you look up above through the origin,
Through the origin, you're going to do a little.
is negative f of negative x. So we have to do both. Basically, we're combining the two steps we just did. We're going to multiply the whole equation by negative. So in my first step, I'm just going to put a negative out front. But then we're also going to do the step we just did, where every place you see an x, you replace it with negative x. So you're going to do the 5 times the negative x minus 9, and then the negative x raised to the second plus 3. Okay. I would always say we always try to start on the inside the most.
Okay.
And it's going to be, I would say, easiest to go ahead and deal with the negative x's, which this inside part's going to be what we just had on the last part, right?
Yeah. Sweet.
But I'm going to leave my negative out front for the moment. When you put negative x in, it's negative 5x minus 9 over
X squared plus 3.
x squared plus 3. Now you have a negative. We're multiplying this fraction by a negative. How do we multiply a fraction by a negative?
Multiply the numerator.
Okay, multiply either the numerator or the denominator, not both. Because if you multiply top and bottom by negative 1, you're multiplying by negative 1 over negative 1, which is positive 1. So if we apply that to the top like we did earlier, this becomes what? 5x plus 9 over x squared plus 3. And this is our reflection through the origin.
Makes sense.
For mine, I just did like negative 5 times negative x minus negative 9 over negative x squared.
As long as you can keep it all straight. And it works out the same in the end, right? That's,
Less steps.
More mental power though.
Not really. You just negative everything on the paper.
Okay, moving along. Example 4 on the back. We're going to talk about stretches and shrinks here. And a big part of what we're going to be doing here is looking at connections. How does vertical relate to horizontal? Because on some of these there are definitely connections there we need to talk about. So you're being asked to state the horizontal or vertical stretch or shrink based on your parent function being x squared. So f of x equals x squared. So as we look at A, y equals 2x squared. What are you thinking?
Vertical stretch.
Yes? No? Vertical
So
stretch by a factor of,
So how do you determine if this is vertical versus horizontal?
okay.
It's a fraction.
So horizontal, two things. A, it has to be x divided by a number. And B, it also has to be in the parentheses. In other words, it has to be in on the x, not just in front of the x squared. Okay, so like if we were going to talk, basically, the ones with parentheses are the ones where we're going to talk about horizontals. Okay, something like this is just your traditional vertical because it's just a number multiplying by x squared. Okay, so if it's a number multiplying by a function, it's your traditional vertical. So in this case then, 2x squared, this is just going to be a vertical stretch.
So we use shrink instead of compression now.
By a factor of 2. And I'm guessing Logan's on the next problem, but it was a stretch because 2 is a number bigger than 1, right? Okay.
Next problem.
No, just in general asking.
Yeah.
The book uses shrink, I think. In all honesty, it's the same. Shrink, compression.
I know it is.
I don't care what you use, but I think the book is going to probably use shrink based on what I have written in my notes. So, okay. B. Y equals 4/10 x quantity squared.
Horizontal shrink. Yeah.
Maybe.
It's shrink because it's less than 1.
Is this in the right form, though, to judge that quite yet?
No.
If we're talking horizontal, which I do want to talk horizontal, the form, if you look on the front side, is x divided by c. Right now, we have x times a number. And that's where we run into the slight piece. Now,
They quit.
let's think about this. Okay. The decimal, 0.4. What do you know about the decimal 0.4?
Less than 1.
Yeah, but if read properly, it is 4 what?
Tenths.
It is 4/10, which could be written as a fraction 4/10, yes? And the fraction 4/10 reduces to be 2/5.
Okay.
I have a plan. Just hang with me, okay? I'm trying to take you somewhere. Now, with that in mind, could I rewrite this instead of saying 0.4x quantity squared? This is an equivalent statement to say 2/5 x quantity squared. Equivalent statement?
Yeah.
I just changed my decimal of 0.4
Yeah.
to the fraction 2/5. Now, okay, so this right now is 2/5 times x,
Okay.
or x times 2/5. If I want this to be x divided by something, x times 2/5. So here, so I'm going to erase this in a moment, sidebar, but x times 2/5 would be the same as x divided by 5/2. Think backwards here. If this was dividing and it was a fraction, x divided by 5/2. What would I tell you to do?
Multiply by the
Multiply by the reciprocal, which is x times 2/5. Could we move this way instead? And I'm trying to get you somewhere, okay? So what I'm saying is that 2/5 times x is the same thing as saying x divided by 5/2. So in order to be able to argue the horizontal aspect, we need to see the appropriate setup. The appropriate setup there is the fact that it's x divided by the value 5/2. Now, let's revisit horizontal stretch or shrink, and by what factor?
by a factor of 5/2. Then it's
So now we're going to talk about this being a horizontal stretch by a factor of 5/2.
Doesn't matter if you put 5/2 and 2.5.
It does not. They're equivalent, as you know. Okay. Now, I'm also going to say or.
no.
Okay. I took you the little bit longer route there because I needed to address horizontal. What if instead 0.4x quantity squared? What if I just apply that square? What is 0.4x times 0.4x?
16.
Yeah.
0.16 x squared. If we change this equation to this form, what would that be in terms of my horizontal and vertical stuff?
Vertical shrink.
Now we're talking that this could be called a vertical shrink.
Well, aren't they the same thing essentially?
I'm getting there. By a factor of 0.16. Thus, the reason here, I'm going to say or. Okay, by design, this problem, they want us to talk horizontal. Okay, Algebra 2, we didn't really talk horizontal. We're pre-calc now. Okay, we're talking about the horizontal. But think about this. Horizontal stretch. Horizontal is left to right. Yes, what's a horizontal stretch going to do? It's going to make a graph longer, wider.
Yeah.
Okay, what's a vertical shrink or vertical compression do?
Shrink it. Now.
It pushes it down, and as it goes down, it gets wider.
Deep and wide.
Are you seeing the connection?
What?
There are different factors there.
Yeah.
Okay? They're different factors, but pushing something down or stretching something out horizontally is going to cause it to push down vertically. Okay? So that's the connection I need you guys to see. I mean, technically on A, we could change that to horizontal. It's just harder to do because it's already multiplied out. Okay?
So which one would we put on the answer?
Whatever stick
Question.
fancy.
Technically, both are correct. I don't remember I don't remember how it presents itself in homework.
So this work, whatever tickles your fancy.
I really don't.
You never do that on me.
I think I have a more. On the horizontal, it says horizontal shrink or vertical stretch in homework. So it's either or.
Yeah.
Okay.
Your fancy
Okay. Is that our good stopping place?
I would agree.
Okay. Monday, we'll pick up with C and D. We'll work through the rest of the page. I would like to think you should have some work time. That shouldn't take us the whole time. I say that and I jinx myself every time now. Homework, you can start working on pieces of it if you want. It will be due Tuesday.